Hello again, algebra students. Today, we're going to continue what we were doing yesterday, which was just simplifying radicals, which are just square roots. And today we're going to be simplifying cube roots. And I didn't mention this in the last lesson, but square roots really undo squares. Squares are exponents. That's why this whole unit goes together with exponents and radicals. Cube roots undo cubes. So what we're looking for here, something cubed is to the third power, we're looking for three of a kind, as opposed to yesterday when we just needed pairs. So what I want you to keep in mind today is perfect cube numbers. We don't need a ton of them. Usually we're going to stick to fairly small numbers. So you may want to write this list down. I think this will be very helpful. Now, 1 cubed is just 1. Dividing anything by 1 isn't going to change anything, so I'm not going to worry about that one. 2 cubed is really 8. So if we can divide something by 8, I know that I'll be able to get 3 2's out of that. 3 to the third power is 27. 4 to the third power is 64. And 5 to the third power 125. There are some other numbers that we will use today, but these are the majority. And in fact, I would say 8 is probably going to be one of our most common numbers that we're going to be dividing by. So if you haven't written this down yet, you might want to just pause the video and write down that list, even just those 4 numbers, 8, 27, 64, 125. Those are going to be really important today. And you're probably going to want to have a calculator handy today because unlike yesterday, a lot of our numbers are going to get really big today as we're working. So it'll be a little bit harder to just do the division in your head. So in the cube root of 54, I did say, think about those perfect cubes. But you don't have to start with those if you're not seeing it immediately. 54 is even. If I would do 54 divided by 2, I get 27. Now 27 was from my list. And I didn't start by saying, hey, 27 goes in here, because you might not see that right away. So if you don't see it, you can start by dividing by 2. There's nothing wrong with that. 27 would be 3 times 9. And then the 9 can be 3 times 3. So yesterday we were just looking for pairs. Today, because of this little 3 right there, didn't line up quite right, but the 3 in that index spot, that's what that's called, reminds me that I need 3 of a kind. So when I do this, I would need all 3 of these circle up, those break out. The only thing that was at the end of the branch that didn't get circled is that 2. Okay, the one thing that I will mention that I often see is that people forget to write that little 3 right there. They're like, oh yeah, we all know that it's a cube root. I don't have to write it. You have to write it. It has to be differentiated from just a regular square root. You have to have that there. So this would be 3 times the cube root of 2. We can't just say rad like we did with square roots. Square roots are more commonly used, which is why it's okay to have that shortened version of that. But this is 3 cube root of 2. For 135, again, if you don't see a perfect cube that goes in there, look for anything that goes in there. Let's start breaking this down. 135 does end with a 5, so I know it's going to divide by 5, right? So that'll be 5, and it's 27, which again is from our list, and we just used it in the last number, in the last problem. I could show this work exactly like I did in the last one, with the 3 times 9 and then split the 9 up. Here's the thing. I think that to save some time, most of you are going to feel comfortable once you see a cube root a couple of times. 27, I know that's going to be a 3, 3, 3. Most of the time, I don't do a 3 to 9 and then a 3 to 3 from there. I just do this, kind of a 3-prong thing, and that's what I do. If you like it better the way that we did it in the first problem, go right ahead. That's just fine. But those will all circle up and break out. The stuff that's left over is my cube root of 5. Now, I said the numbers get big pretty quickly. So these two would both be examples of that. The first one here, this 1,728, it's even. I know 2 goes in there. And if I know that 2 goes in there, I'm going to try dividing by 8. You could start with a 2 and do a whole bunch of separate divisions, but on my calculator, if I try 1728 divided by 8, it's 216. Okay, now the 8, this first time, I'll do kind of the slower way, but 8 is 2 times 2 times 2. I'm going to show this as a 2 times 4 and then say, oh, that's going to be a 2 and a 2. So I could circle up those 2's. Or if you are comfortable with this, like we just did with the 27, and again, 8 is going to get used a lot. I usually do this. There's a pair, or not a pair, a triple. 216 is also, it's not done, right? And 216 is actually kind of a nice number for us to use, even though I didn't put it in my list, because it happens to be a perfect cube as well. But you might not see that. I didn't put it in the list because it's not going to be used a whole lot today. But if you get to a problem like this and you're like, oh, I don't know, does 8 go in there? 216 divided by 8, I do get a nice answer. I can have 8 times 27. That 8, we just did an 8 over here, so I could do another 2 times 2 times 2. Got it. 27, we've already done that. That's a 3 and a 9, or 3 times 3 times 3. This number, 1,728, happens to be a perfect cube. And I know that because there's nothing left that didn't get circled. The first triple that I circled came out as a 2. The next triple that I circled came out as a 2. And then the last one came out as a 3. And there's nothing left over as a cube root. So 2 times 2 is 4, times 3 is 12. This doesn't have any radical or cube root part left over. And if you want to check this, 12 to the third power, 12 times 12 times 12, is 1,728. Not a number that I have memorized, probably not a number that you have memorized either, but it does work. For 4,912, even bigger numbers this time. Again, it's even. So I would start trying any of these even numbers by dividing by 8. And this does divide nicely by 8. It's going to be 8 times 614. So the 8, again, you could do a 2 and a 4 and then split up the 4, or I can just do 2 times 2 times 2. There's my triple. That breaks out. 614 does not divide nicely by 8. I get a decimal if I try that. So 614 is even though. So I could divide it by 2 to just see what I've got. That's going to be 2 times 307. Now, 307 may have some other factors. However, that list that I made at the beginning, if I try to divide 307 by 8, it won't work. Dividing by 27 doesn't work. It won't work with 64. And 125 was the last one that I had there. 125 doesn't go into here evenly either. So maybe there are other numbers that I'm not thinking of that go into 307, but there's certainly not 3 of them. There won't be another triple that can come out of there. So I can break this 2 out. The stuff that's left over from my cube root, that 2 and the 307, both just go back together. I would not leave 2 times 307. It would just be back to that 614. I know that that wasn't the end of a branch, but if I would multiply these 2 branches together, that gets me back to my 614. In the problem on the left, the cube root of 160. Well, that one clearly will divide by 8 nicely. 8 times 20 would be 160. So the 8 is going to be a 2, 2, 2. 20, I'm not seeing a perfect cube, but if I would do like 4 times 5, and then I get a 2 and a 2, well, I've got this triple. But all the other stuff, I don't have 3 of a kind. So that just all gets put back together into one number. So that 2 breaks out. I'll have the cube root of 2 times 2 times 5 is 20. That was like the beginning of that branch that didn't split up at all for me. So 2 times the cube root of 20. The problem on the right is the first time that we're seeing a problem where there's a number out in front. That was a variable that was after that -5. We call the -5 a coefficient. This isn't really a coefficient, it's just a number out in front of this. This is -5 times the cube root of 162. Now, with the -5 out in front, that just multiplies by any other number that we're able to break out of our cube root. So for right now, I'm just going to say, you know what, don't really worry about that -5. What can I do with the 162? It's not divisible by 8. If you try that, you get a decimal. But it is even. So let's start with dividing it by 2. And that'll give me 81. All right, well, 81 could be a 9 times 9. And then this can be a 3 and a 3. And this can be a 3 and a 3. So I definitely have 3 of a kind. I actually have an extra 3 that won't get circled. I'm going to circle these 3 as my triple. I have a -5 that's outside already. That circled up triple 3s breaks out, that's a 3. The stuff that's left over as my cube root, I have a 2 that was at the end of a branch, and I have this 3 that was at the end of a branch. That would give me 6. Now, when I simplify this a little bit more, that -5 times 3, we're not going to leave that. That'll be a -15 times the cube root of 6. Now, if you had known that, the way that this would work out, you might have looked at that 162 and taken my advice at the very beginning that I purposely ignored right there and said, oh, well, 8 doesn't work, just 27. And it would have. We could have split it up that way to get 27 times 6, which would give us the same end result. All right, some really big numbers here. However, all those zeros are kind of nice. I stopped with just those 4 perfect cube numbers. However, when I look at something like 7,000, again, I'm going to ignore the 6 for a second. I would say, well, let's do 7 times 1,000. And 1,000 could be 10 times 100. Oh, and instead of splitting up like a 10 into a 5 and a 2, let's say, oh, that can be a 10 and a 10. 1,000 is 10 to the 3rd power. So I've got a triple 10 right here. Those can break out as a regular 10. And then the only thing that I've got left over is that 7. So I had a 6 out in front. I'm going to break out that 10. And then the stuff that's left over as a cube root is just the 7. So this is going to be 60 times the cube root of 7. We're going to kind of take that advice a little bit on this next problem as well. If I know that 1,000 is really 10 times 10 times 10, I could take this 40,000 and let's split it up into 40 times 1,000. Now that 1,000, I could do it just like I did in the last problem, or now that we know this, I could do a 10 times 10 times 10 triple. Circle them up. 40 now also has a perfect cube in it, right? I could split it up several different ways, but I would look at this one and start with 8 times 5. 8 is going to be a 222. Circle up my triple. Here's the only thing that didn't get circled. So I had my 2 outside originally. I circled up a triple 2, and I circled up a triple 10. And my leftover is just going to be that 5. So I'll have 2 times 2 is 4 times 10 is 40 times the cube root of 5. That's how we simplify cube root kind of problems. Your worksheet today is simplifying cube roots. Keep that list handy. You might even want to extend it and have more perfect cubes, but again, if you know 2 cubed, 3 cubed, 4 cubed, 5 cubed, most of the time those are the numbers that you're going to need. The answer key is going to be in Schoology, and then there's going to be a quick formative for you. Let me know if you need any help.